My name is Art McDonald. I'm a professor emeritus at Queen's University, and I received the Nobel Prize in Physics this year, along with the Breakthrough Prize in Fundamental Physics, which was won along with my Sudbury Neutrino Observatory collaboration colleagues. I've been visiting India for the last few days. I spoke at the All India Science Congress and was very impressed with the speech by Prime Minister Modi, who emphasized science and development of technology, a broad spectrum of pure and applied science as things that his government was supporting, and also the relationship to the environment in the future research that is being done. It was interesting to compare that with my interactions with the new science minister, Christy Duncan, who was present in Stockholm in December for the presentation of the Nobel Prize. And I observed very positive similarities between the two agenda for science and technology in our two countries. Again, in Canada, the openness associated with the publication of the ministerial mandates, the appointment, which is planned, of a chief science officer, chief scientist, that is, the emphasis on evidence-based decision-making within government is something that I welcome. Our project, which takes place at the Snow Lab facility, 2 kilometers underground in Sudbury, Ontario, started with the Sudbury Neutrino Observatory project, of which I was the director. And it is that project for which those prizes were awarded. Using that detector, after development over a period starting in 1984 and lasting into the 2000s, we were able to show that neutrinos produced in the core of the sun definitively change from one neutrino type to another before reaching our detector, a property that is beyond the standard model of elementary particle physics and implies that they have a mass greater than 0. It is this fundamental information that allowed us to achieve these prizes, and it was done with an international collaboration. In our case, the UK and Britain and the United States as well. And that's the typical situation with respect to future experiments that are taking place in the expanded Snow Lab, where we are understanding neutrinos and the sun and other very basic properties of how the universe evolves, including attempts to measure directly the dark matter particles that we now know are much more massive than neutrinos, but also have the ability to penetrate through the 2 kilometers of rock to our detectors. And we hope to have the most sensitive detector when we are obtaining our results from the DEEP experiment within the next few months in that facility. So it's a pleasure to see the similarities between Canada and India, which is about to begin an underground neutrino observatory, in the interest in this basic science and in the similarities in terms of government policy towards basic science. Very gratifying to me to see this approach in the two countries. We also hope that we will have good educational opportunities. We already have scientists from India working on one of the experiments at Snow Lab, and we're hoping that that and the addition of further students will occur, which would be much appreciated by our scientists. One aspect of the scientific and innovation policies of the governments of India and Canada that I welcomed was an emphasis on a balance between the pure research and applied research. The mix of the two is very important in order that one has in the applied areas the latest in innovation by having connection with scientists who are working at the frontiers of their fields. And so I welcome the future results as a result of these sorts of approaches to scientific support, or support for scientific research.